Snakes. Nature's all-terrain vehicles. Adaptable, efficient, and surprisingly elegant in their simplicity. These creatures are a masterclass in engineering. Every movement is study in precision and efficiency. They navigate diverse terrains with ease, traversing land and sea, and even tight spaces. Inspired by these natural wonders, engineers have created snakebots. More than just technological achievements, these robots are multifunctional tools for a range of modern applications. Imagine a robot that can maneuver through debris for search and rescue missions, access confined areas for maintenance tasks, and conduct thorough inspections for dangerous settings. Plus, they look really cool. Well, that's all the motivation I need. Let's build a snakebot. The general concept behind this robot is to create a repeating module with a servo motor on each end to control the X and Z axis. Connecting enough of these together will hopefully give the robot enough degrees of freedom to pull itself forward, and to create a variety of positions to be able to maneuver through different environments. Each module will be made up of 3 parts: the body block, and a servo mount on each end to properly position each motor. Each of these parts will be separately printed in PLA plastic. And here are the 3 completed parts. There is also a small mounting block that the motors will screw into, but I forgot to record that. So to put this together, each of these parts pretty much screws together with some M2 screws, and the servos just screw into those. You can kind of get an idea here of how these motors will move along each axis. And of course, I made not just 1, but 5 of these. So the first thing I did was connect 2 of them together to try to get some sort of working pattern. This part was actually fairly simple and definitely made me overconfident for the rest of the build. It gets a lot more complicated from here. The next thing I did was double the modules from 2 to 4. I figured this would give me a better idea of what it would actually take to make this robot move. After hours of work and many failed experiments, I did finally find a few patterns that I found promising. There was an issue that I was aware of with the lack of friction. Most of the other builds like this that I have seen on YouTube eventually resort to adding wheels and basically making more of a train than a snake. So I decided to set a hard rule against this and to solve it some other way. The last thing I needed to make was a mounting block for all of the electronics, and I thought clear resin was a pretty cool choice for this. Here is the completed robot. You can see I've added rubber grips to the bottom to help build up friction between the robot and the surface it's moving along. I also switched from an Arduino Uno to an Arduino Nano to make the robot more compact. It's actually sitting inside of the electronics mount. Another issue was the robot was hollow and really lightweight, so that prevented it from building up friction as well. The electronics component was weighing it down on its end, so I added a fishing weight inside of the module on the other side to add weight and balance the whole thing out. Now it's time to test this prototype and see what it can do. Overall, I'm quite pleased with its performance. It does have a tendency to rock side to side a little bit due to the weight that I added in the end, but I think that's easily solved in future versions of this. and here it is a little faster to really get a sense of how it moves over time. A little bit about the code. It moves the motors in a timed, wave-like pattern. This allows each module to sort of pull itself forward. Overall, this prototype turned out pretty well. It's mostly limited to the quality of its parts, and that gives me the confidence I need to continue this idea and go ahead and make a version 2. The weight in the end of the robot did eventually strip the screws and cause this to happen, so that's the end of testing for now. So I had a lot of fun with this project. It was a really good learning experience, and I learned a lot that I'll be able to apply towards the next iteration of this build. Definitely better motors, probably better 3D printed parts, better design overall, and I'll probably add some cool things like cameras and end effectors. So if you want to see an updated version of this robot, subscribe and I'll have that video out soon. Thanks for watching.